Now we are going to go through some electrophilic aromatic substitution reactions. So in the center of the page, I've drawn out benzene, and I've put 5 reaction arrows going around it. So if you'd like to pause the video, work on these by yourself, and then we will talk about how to solve them. So using that basic mechanism that we drew out for electrophilic aromatic substitution, let's go through these. So for this first one, we're going to end up with our benzene ring. And then remember, with these reactions, we replace the H with an electrophile. So in this case, our electrophile is this structure right here. We're gonna bond this carbon to the benzene, and then the double bond O and the R will remain. Now, if you're confused on how I got this, again, there's a video on the EAS mechanism that I have posted previously. So this reaction right here that we just did is called Friedel-Crafts acylation. Okay, for the next one, we have an R group bonded to a Cl. Now you'll notice that the group on our electrophile that leaves, in this case, previously it was a Cl. Again, it's going to be a Cl. The reagent on the bottom, which acts as a base, will also have that halogen in there as well. So like in this next one, you'll see we have Br2 with FeBr3. So that's a pattern that shows up with these reactions. But with this reaction, we're going to replace the H with the R group. So this reaction is called Friedel-Crafts alkylation. And the structure that results looks like this. And then the R group, that can be any carbon chain. So you can put pretty much any R group you want on here and attach that to your benzene. Now for this reaction with Br2 and FeBr3, as you can probably guess, we're going to put a Br on the benzene ring in place of the H. This reaction is called bromination. You can also do this reaction with Cl2 and FeCl3, or excuse me, Cl2 and AlCl3, and you would get a chlorine here, and that would be called chlorination. This next reaction, we have H2SO4 with heat. Now, this reaction is called sulfonation. Now you might think that with H2SO4 we're gonna protonate, but remember we already have an H here. So what we end up adding onto our benzene is an SO3H group. And then finally, this last one, this is called nitration. And what we are going to add in place of this hydrogen here is an NO2 group. So here are some reactions that we can do with electrophilic aromatic substitution. And if you did not understand how I was able to solve these, check out the basic mechanism on EAS.